Hello everyone, this is Tanvi and I'll be presenting World Weather Report for 28 to 26th of January 2020. So firstly, I'm going to discuss about the cyclones which were formed in this particular week. So the first cyclone here is Dine, which was formed in South Indian Ocean. On Jan 24 by 4 pm EST, Dine formed just 38 nautical miles northwest of Port Louis, Mauritius. On Jan 25, Dine reached maximum sustained winds near 45 knots, that is 52 mph or 83 kilometers per hour, and the strength was maintained until early of Jan 26. At 4 pm EST on Jan 26, the Joint Typhoon Warning Center issued the final warning on Dine. At that time, Dine was located near latitudes 23.8 degrees south and longitude 70.1 degree east, about 746 nautical miles east-southeast of Port Louis, Mauritius. Maximum sustained winds dropped to 40 knots and were weakening because of vertical wind shear. On Jan 27 at 4 pm EST, the moderate resolution imaging spectroradiometer instrument that flies aboard NASA's Aqua satellite provided a visible image of Dine that showed wind shear had taken a final toll on the storm. The Moody's image revealed that the bulk of clouds associated with the former tropical storm has been blown to southeast of the weak center of circulation and Dine was dissipating. So this is the image of dissipating cyclone Dine, which was taken by the Moody's satellite on 27th of January. So the next tropical cyclone was named Izumi, which was also formed in the southern Indian Ocean. Tropical cyclone Izumi formed on January 24 at 4 pm EST, about 764 miles east-southeast of Port Louis, Mauritius. Izumi's maximum sustained winds peaked the next day on Jan 25 at 45 knots, that is 42 miles per hour or 83 kilometers per hour. On January 26 at 4 pm EST, the Joint Typhoon Warning Center issued their final warning on tropical cyclone Izumi. At that time, Izumi had weakened to a depression with maximum sustained winds near 30 knots. It was located near latitudes 29.8 degrees south and longitude 77.9 degrees west, about 1,260 miles east-southeast of Port Louis, Mauritius. The depression was moving to the south-southeast and was dissipating. When NASA's Aqua satellite passed over the southern Indian Ocean on Jan 27 at 4:05 am EST, the moderate resolution imaging spectroradiometer of Moody's instrument provided a visible image that revealed the remnants of the Izumi were dissipating. So there was this another cyclone, tropical cyclone named 12P formed in the southern Pacific Ocean. It was formed on January 25 at 10 am EST, about 142 nautical miles southeast. That was the peak for 12P as maximum sustained winds reached 35 knots, that is 40 mph. On January 26, the Joint Typhoon Warning Center issued their final warning on tropical cyclone 12P at 10 am EST. At that time, 12P had weakened to a depression with maximum sustained winds near 25 knots. It was located near latitude 22.4 degrees south and longitude 166.4 degrees west. The depression was moving southeast and weakening to a remnant low pressure area. By January 27, the remnants of 12P were dissipating under adverse conditions. NASA's Aqua satellite passed over the southern Pacific Ocean and the moderate resolution imaging spectroradiometer instrument provided an infrared view of the depression at 6:50 am EST. Moody's found one small area of powerful thunderstorm remained where temperatures were as cold as or colder than minus 70 degrees Fahrenheit, that is minus 56.6 Celsius. NASA research has shown storms with cloud top temperatures that cold and high in troposphere have the ability to generate heavy rainfall. That area of heavy rainfall was quickly dissipating. 12P's remnants were expected to dissipate later in that day. So as we can see in this chart, it gives the dates and the times and the progression of the cyclone. So on 26 January at 2:30, it was C1 type cyclone. C1 is category 1 cyclone, and as we can see at 27, it became a D. That means it is a depression. So it was dissipating from 26, 25 to 26 and 27. So these are the satellite images of the storm Dine and storm Izumi, which I have taken from the Zoom Earth website. So it shows the path of the cyclones in both the images. The both images are quite similar because both the cyclones were formed in quite close vicinity. But the green part here is for the cyclone Dine and the blue part here is for cyclone Izumi. So accordingly, we can see that this table shows dates, time, the depressions of the storm, the category of the storm, wind speeds, and the pressures. So cyclone Dine was formed on 25th of January as a moderate tropical storm with wind speeds 85 km per hour, and more or less the wind speed changed by plus minus 10 km per hour, and the pressure levels also changed accordingly, and on 27th of January, it later dissipated further that day. Similarly, in the cyclone Izumi, it was formed on 25th of January, similarly represented by S, which is moderate tropical storm with speed 70 km per hour. This cyclone also goes on dissipating from 25th to 27th of January. On 26th of January, it became a depression with wind speeds 70 km per hour, and the pressure reduced to 996. That is 1 MB reduction of pressure. And then on 27th, it became a mere disturbance with wind speeds of 50 km per hour. A large cyclone over entire North Atlantic was developed on January 25, which brought widespread windstorms to its south and headed towards UK, France, and Ireland. The cyclone is dominating in whole North Atlantic with central pressure between 955 and 960 millibar. Its center just west to the Iceland. However, several vortices are even seen pronounced, likely 3 to 5 vortices are seen in the satellite imagery. The strongest pressure gradient remains across the strait between Iceland and Greenland, but the pressure gradient is also increasing south and southwest of the low, meaning winds are strengthening and are spreading towards Western Europe as well. The system is very large compared to the continent Europe, around two-thirds of the continent. The main cold front is moving across the North Sea, passed over UK, that is today's afternoon, that is 27th of January, and continues towards east. Several vortices or waves embedded in the large circulation are well visible. These were all the earthquakes that occurred in the particular week. On 22nd January, it occurred in Turkey with magnitude 5.6 MW. MW is the moment magnitude scale, which is generally used for earthquake magnitude in respect of size and strength based on its seismic moment. That is a measure of work done by the earthquake. On 23rd January, it occurred in United States, Alaska, with the magnitude of 6.2 MW, and again on 24th January, it occurred in Turkey with 6.7 MW, which caused a lot of disaster and injuries to the human life. So now I will be discussing about the temperature variations for January as a whole. I did not find any particular events in the particular weeks, so I'll be describing in short the temperature variations for the entire month. So the first month of the year was characterized by warmer than average temperatures across much of the world's land and ocean surface. The most notable warm temperatures were observed across much of Russia, Scandinavia, and eastern Canada, where temperatures were at least 5 degrees Celsius above average. Other notable warm temperatures were observed across part of eastern contiguous US, Central Europe, and eastern Australia, while the temperatures were more than 2 degrees Celsius above average. Meanwhile, the most notable cool temperature departure from average were observed across much of Alaska and part of western Canada. Record warm January surface temperature present across parts of Scandinavia, Asia, the Indian Ocean, the Central and Western Pacific Ocean, the Atlantic Ocean, and the Central and South America. However, no land or ocean areas had recorded cold January temperatures. North America had its 16th warmest January in 111-year record. South America, January 2020, had second warmest January on record with positive 1.37 degrees Celsius temperature. Only January 2016 was warmer. Europe had its second warmest January on record with temperature departure from average of positive 3.16 degrees Celsius, trailing behind the record warm January of 2007 which had positive 3.32 degrees Celsius. January 2020 for Asia was 3.46 degrees Celsius above average and the second highest for January on record. Oceanic areas had its third warmest January on record at plus 1.61 degrees Celsius, trailing behind 2019 and 2013 records. Australia's mean temperature during January 2020 was 1.45 degrees Celsius above 1961 to 1990 average, resulting in the third warmest January in the 111-year record. So now I will be discussing about heavy rainfall, floods, hailstorms and blizzards that occurred between 20th to 26th of January worldwide. The current map shows rainfall accumulation from January 15 to 21 in New South Wales and neighbouring states. The data remotely sensed estimates that comes from Integrated Multi-Satellite Retrievals for GPM, a product of the Global Precipitation Measurement Mission. Local rainfall amounts may be significantly higher when measured from the ground. According to the news report, the largest accumulation was in New South Wales, occurred north of Sydney, where rainfall averaged between 20 and 30 centimeters, that is 8 and 12 inches. In Victoria, areas near Melbourne received months' worth of rain in a single day. The weather system was spotty, however, and some areas along the southeast coast saw less than a centimeter of precipitation. The rain could not extinguish every fire, but it helped reduce the numbers. According to the New South Wales Rural Fire Service, 64 fires, 16 uncontained, were burning across the state on January 21. That's down from 88 fires, 39 uncontained on January 15. When the rain ended, the total were not enough to bring any area out of drought. That is a concern, as the Bureau of Meteorology noted on January 21 that high temperatures and gusty winds have once again elevated the fire danger across New South Wales, Victoria, and southern Australia. A catastrophic hailstorm hit Australia's capital city Canberra on Monday, January 20, 2020. Houses, cars, properties, and buildings were severely hit by hails up to 5 centimeters, that is 2 inches wide, and among the worst affected institutions were the CSIRO, with huge holes seen in the roofs of dozens of its glass houses where experiments had been underway for over 2 years. 65 of CSIRO's glass houses were affected, destroying decades of hard work. National institutions, including the National Museum of Australia and the Royal Botanic Gardens, were closed on Tuesday, January 21, due to damage inflicted by the storm. The devastating storm disrupted power to over 1,000 homes across the territory, with emergency services attending to over 1,900 calls for help. A rapidly intensifying winter storm brought intense blizzard conditions to part of Newfoundland and Labrador, Canada on Friday, January 17, 2020, forcing St. John's authorities to issue a state of emergency. Epic snowfall rates of more than 10 centimeters, that is 3.9 inches per hour, were falling in St. John's at times through Friday morning. By the lunch hour, over 30 centimeters, that is 11.8 inches, were already on ground in the city, and there is plenty more to come. Hurricane force winds in excess of 130 km per hour, that is 80 miles per hour, were expected, and 40 to 70 plus centimeters, that is 1.3 to 2.3 feet of snow in some areas. Higher than normal water levels along the east and northeast coast due to 60 to 80 centimeters of storm surge combined with 9 to 12-meter waves were formed from the late evening until early Saturday afternoon. Flooding and damage to coastal infrastructures happened, especially in locations exposed to the north. Highest water levels were expected near high tide on Friday night and again till early Saturday afternoon. Flooding in Mozambique, Africa. According to a report from the UN Office for the Coordination of Humanitarian Affairs of 21 January 2020, at least 28 people have died and more than 58,800 have been affected by heavy rains and flooding in Mozambique and the surrounding area. More than 10,200 houses have been damaged or destroyed, including 2,589 completely destroyed, and at least 47 schools have been affected. Thousands of hectares of crops have been damaged or destroyed less than 2 months before the planned March harvest. The OCHA report warns that in the last 24 hours, water levels have started to rise across Sofala province and the surrounding area, all of which were affected by Cyclone Idai in March 2019. Zambia floodings. Around 500 people have been displaced by further wave of flooding in Zambia's eastern province. Local media reported damage by flooding more than 100 homes, a school building, and a bridge in Mambwe district. Many of the displaced families have been housed in the local school. Local authorities expect the number of those in emergency accommodation to rise over the coming days. Flooding first affected the region in late December 2019. By 1st January 2020, over 200 families have been displaced. Eastern province borders Mozambique, where recent flooding has left 28 dead and affected over 58,000. Recent flooding in southern province of Zambia has increased fears of food security after destroying crops in areas already facing food shortages after several drought. Flooding in Madagascar. On 21st January, it was reported that at least six people had died in floods and landslides in several parts of the country during a period of heavy rainfall from 7th of January with more severe weather. Since then, the country's National Office for Risk and Disaster Management has reported further severe flooding in the at least 7 regions of the country. On 23rd January, BNGRC said that 13 people have died in recent flooding, which has affected over 47,000 people in the regions of Diana, etc. A total of 7,786 homes have been flooded, with around 45 completely destroyed. Damage to homes has forced around 3,000 people to evacuate. Several national roads have been closed and wide areas of crops are damaged. These were all the earthquakes that occurred in the particular week. On 22nd January, it occurred in Turkey with magnitude 5.6 MW. MW is the moment magnitude scale, which is generally used for earthquake magnitude in respect of size and strength based on its seismic moment, that is a measure of work done by the earthquake. On 23rd January, it occurred in United States, Alaska, with the magnitude of 6.2 MW, and again on 24th January, it occurred in Turkey with 6.7 MW, which caused a lot of disaster and injuries to the human life. Flooding in Spain, Europe, caused due to the storm Gloria, which reached 3 kilometers inland. A severe storm brought powerful winds, cold temperatures, snow, and coastal flooding to widespread areas of Spain from 20 January. At least four deaths were blamed on the storm. Satellite image shows storm surge swept 3 kilometers inland in Tarragona province, resulting in severe damage to rice paddies and the ecosystems. So now I will be discussing about heavy rainfall, floods, hailstorms, and blizzards that occurred between 20th to 26th of January worldwide. The current map shows rainfall accumulation from January 15 to 21 in New South Wales and neighboring states. The data remotely sensed estimates that comes from Integrated Multi-Satellite Retrievals for GPM, a product of the Global Precipitation Measurement Mission. Local rainfall amounts may be significantly higher when measured from the ground. According to the news report, the largest accumulation was in New South Wales, occurred north of Sydney, where rainfall averaged between 20 and 30 centimeters, that is 8 and 12 inches. In Victoria, areas near Melbourne received months' worth of rain in a single day. The weather system was spotty, however. Over India and the northern and northwestern part of India, there were a set of western disturbances, which are cyclonic circulations, lies over the eastern part of Jammu and Kashmir and moving east northeastward. Again, there was a fresh western disturbance on 24th of January night, and again on 27th of January onwards, there was a new set of western disturbance. Western disturbance is an extratropical storm originating in the Mediterranean region that brings sudden winter rain to the northwestern part of Indian subcontinent. It is a non-monsoonal precipitation pattern driven by the westerlies. The moisture in the storms usually originates over the Mediterranean Sea, the Caspian Sea, and the Black Sea. Extratropical storms are global phenomenon with moisture usually carried in the upper atmosphere, unlike their tropical counterparts where the moisture is carried in the lower atmosphere. In the case of Indian subcontinent, moisture is sometimes shed as rain when the storm system encounters the Himalayas. Western disturbances are more frequent and strong in the winter seasons. As we can see the propagation, they come from Mediterranean and the Caspian and over the Indian subcontinents and move northeast and eastwards. Northeastern Russia, Yakutia region, Siberia is well-known place for extreme cold, with few stations being the coldest areas in the northern hemisphere. There are towns where record cold low temperatures are at 67.8 degrees Celsius and minus 71.2 degrees Celsius. This weekend, the pattern over that part of Asia brought a strong upper level ridge, resulting in development of the surface high pressure system. This usually means the extremely cold will become even more brutal, and so it did. Several stations in Yakutia region recorded down to minus 57 degrees Celsius. Detailed daily extremes for various stations through this month, January 2020, noticed the daytime maximum temperatures are not really much higher. They even stayed below minus 50 degrees Celsius. Indeed, there is a polar night and the thermal inversions are so intense there is hardly anything which could mix the air mass cold pools in the valleys. Stratospheric warming. The polar vortex usually reaches its peak strength in late December and January. As we head further into January and February, the polar vortex starts to slowly lose its strength as the angle of sun is increasing and warming the upper atmospheric polar regions. That means the polar vortex is not able to defend against upcoming attacks which are coming in waves. The standard to measure the speed of stratospheric polar jet stream at 10 MB level, that is 20 to 30 km altitude at 60° north latitude, that is along the polar circle, which we see in the graphics. A slow reduction in strength of polar vortex is typical for late January as the upper level of the atmosphere are slowly starting to warm again as the angle of the sun is starting to increase over the polar region. Polar vortex gains strength and power when the upper levels are cold as the temperature difference with lower latitudes drives the strong stratospheric jet stream. As the upper polar region starts to warm again, the contrast starts to reduce and the strength of polar vortex reduces over time. Currently, the vortex, that means on 23rd of January 2020, is in a pretty good shape with relatively cold core and a wide wind field. This is a plot for geopotential and temperature at 10 HPA and is connected with troposphere, that is lower atmosphere where all our weather is, helping to maintain the current circulation pattern. In around a week, that is on 29th of January 2020, a temperature wave is expected to enter the surf zone of the polar vortex from top of the stratosphere downwards. The warming is set to appear over the Siberian and East-Asian sector. Flooding in Spain, Europe, caused due to the storm Gloria, which reached 3 km inland. A severe storm brought powerful winds, cold temperatures, snow, and coastal flooding to widespread areas of Spain from 20 January. At least four deaths were blamed on the storm. Satellite image shows storm surge swept 3 km inland in Tarragona province, resulting in severe damage to rice paddies and the ecosystems. These are all the references from where I have taken the information and the pictures for the presentation, and all the rest of the terms I have explained in my report in detail. Thank you.